Ask My Instructor 8.7.24. Find the volume of the described solid of revolution below, or state that it does not exist. We're looking at the region bounded by f of x and the x-axis on the interval going from 0 to infinity. And we're revolving that region about the y-axis. We need to give an exact answer using pi as needed. Let's review. Revolving this rectangle of width dx about the y-axis results in a cylindrical shell with radius x, height f of x, and thickness dx. Since the shell has a radius of x, the circumference of the shell is 2 pi x. If we slice the shell open and roll it out, we have a box that has a height of f of x, a length of 2 pi x, and a width of dx. And so the volume of the box, and therefore the volume of the shell, is 2 pi x f of x dx. Now if we add up all the shells going from x equals a to x equals b, we're just finding the integral from a to b of 2 pi x f of x dx, where 2 pi x f of x dx is the volume of just one shell. Now in our problem, a is equal to 0 and b is equal to infinity. So I have an improper integral. And the way that we handle an improper integral is we use the limit process. And I'd like to just briefly talk about the limit process. With the limit process, what we're doing is we focus on the integral from 0 to b, where b is to the right of 0. And then we extend b further and further out towards infinity. All right, let's do a quick recap. The volume of the solid when the region bounded by f and the x-axis on the interval from 0 to infinity, when that region is revolved about the y-axis, the volume of the solid is the limit as b goes to infinity of the integral from 0 to b of 2 pi x f of x dx. Now we know what f of x is, so we just plug that into our integrand. And so we are now ready to find the limit. Well, actually not quite yet. Before we find the limit, let's find the proper integral from 0 to b. So let's evaluate. First, what I'd like to do is just pull my coefficients to the outside of my integral. Once I do that, I focus on answering the question, what kind of u substitution would help me integrate this? The best u substitution in this case would be u equals x plus 1. And do you see the x plus 1 in the parentheses there? So that's a pretty simple but powerful substitution. If u equals x plus 1, then du equals dx, and I also need to know what x is, so solve for x. X is equal to u minus 1. So let's make the substitution, and we will have to think about the boundaries, but let's first just do the substitution of the integrand. Instead of the x, I put in u minus 1. Instead of the x plus 1, I put in u. Okay, now I'm ready to focus on the bounds. Now keep in mind that whatever x is, u is going to be 1 more than x. So if x equals b, u is going to equal b plus 1. And if x equals 0, u is going to be 0 plus 1. So, my next job is to rewrite the integral in a manner conducive for finding antiderivatives, and then to integrate. Now, if I can't do that, then I might question my choice of a u substitution, but you'll see that this will be pretty easy. We take u and divide it by u to the 3, take 1 and divide it by u to the 3. Doing that, I have u to the negative 2 minus u to the negative 3. Now I write it that way so that I can use the power rule. So go ahead and integrate. And after we integrate, we have to evaluate. But before we evaluate, let's do a little cleanup. That's a lot of negatives. What I'd like you to do is to notice that this expression can be rewritten in this way. And then if I just have the two terms change places, it looks even prettier. So what I'm going to do is I'm going to use that equality to make the evaluation a little bit easier. Okay, so evaluate it at b plus 1 and then subtract the evaluation at 1. And this is what we get. A little bit of cleanup on that right-hand piece gives us 9 pi. All right. I think we're about ready to take the limit. So let's find out what happens as b goes to infinity. Well, as b goes to infinity, b plus 1 certainly goes to infinity. And 1 over 2b plus 1 squared, that, since the denominator is going to infinity, the whole thing's going to go to 0. Also, 1 over b plus 1, that'll also go to 0. All right, so the limit is going to be 18 pi times 0 minus 0 plus 9 pi, which is equal to 9 pi. And so the volume of the solid is equal to 9 pi. Take care. Let me know if you have any questions. Have a nice day.